Good morning, teachers. Today, I'd like to give a presentation about my Cambridge project, improving the durability and sustainability of footwear. Extraction of the Agaricus spiceworus mushrooms fiber for the sole of shoes. My name is Cornelis Jefferson, and my team includes Aurelia Hu, Rexon Olsen Indahang, and Jenny Alia Gunawan of Class 12.
Our aim for this research is to go beyond traditional shoe productions, combining creative idea with a global missions. Its main objective is not only to change the way we make shoes and address environmental issue, but also to showcase innovative thinking and a strong commitment to preserve a healthier planet. By using eco-friendly materials and innovative design, these research aim to create a shoe that are not only environmentally responsible, but also represent a shared vision for a more sustainable future. The questions for this research is it possible for footwear that is made out of mushroom fiber to help with improving our health and reduce environmental waste? Background research. Through this study, we want to reduce the amount of waste from shoe by using mushroom extract. Around 22 million of shoes are thrown away each year, which leads to environmental problems, since it takes a long time, around 25 to 80 years to decompose. Therefore, there is a need to embrace proper approach to reduce the waste. After deciding that fiber extract of mushroom were the solutions we researched, their impacts on the environment and how they work. Mushroom contains various fiber. The fibers from the mushroom will be extracted from the Agaricus spiceworus mushroom. This extract has potential to provide additional benefit in making sandals. These benefits include increased durability, flexibility, lightness, antibacterial properties, which can be used for wound dressing and innovative aesthetic in terms of texture.
Polyurethane is a class of biodegradable polymer and happens to be quite eco-friendly, as the method to obtain it produces a very small amount of CO2 emissions. So, its environmental impact is reduced. It is recyclable and does not affect pH levels in soil or water when disposed of, therefore having very little negative impacts to the environment. And next I want to discuss chitin. Chitin is a complex organic compound that serves as a structural component in the exoskeletons of arthropods, the cell walls of fungi, and the medulla of mollusks, like snails and squids. Chitosan, another complex organic compound, is a natural biopolymer derived from chitin, which is primarily found in the shells of crustaceans and cell walls of fungi. And in our project here, our hypothesis is the mushroom fiber is more durable and more environmentally friendly than regular shoes. The materials and equipment used in this project were an electric stove that heated up to 80 degrees Celsius, 2 Ns of NaOH, sodium hydroxide, where N represents normality, a unit of concentration. Others include beakers, flasks, pipette, and burette. And we used about 200 grams of the Agaricus spiceworus mushroom, also known as the button mushroom. And to measure the pH of the solution, we used the pH meter. And we also use 30% concentration of H2O2, hydrogen peroxide, which was to oxidize the solution, 5 grams of MnO4 manganate, which was to catalyze the reaction, and 1 m H2SO4, 1 mole per liter of sulfuric acid to neutralize the solution.
Now for the methodology. So for the methodology, first we use the NaOH crystals and we added them to the water. Following that, the mixture is stirred and shaken and then placed in a container with the same environment. The container that we use is then labeled 10N, where N represents normality, as explained before. The resulting 10 normality container was diluted into solutions of 8, 6, 4, and 2N. Following that, the Agaricus spiceworus mushrooms were weighed and crushed into small pieces, where NaOH solution was then used to place the mushroom under alkaline conditions in a temperature and controlled environment at about 80 degrees for 2 hours. We then placed the solution in a water bath, and the resulting product was then reacted with the H2O2. Following there, we added sulfuric acid until the pH was at a stable level of 7, and we tested this by using the pH meter as explained before. And finally, for the final step, we filtered the solution and only the solid residue was taken. After we get the residue, We wrapped it in aluminum foil and we dried it under the sun over a heat source for a few hours. The residue is then crushed by a mortar and pestle until the fibers have separated into smaller pieces. We then incorporated dietary fiber, which is fiber is mixed into the polyurethane and a round plug. About 4 grams, 2% of the total weight of the polyurethane is then used. Half of this mixture is poured into containers and allowed to dry first. Only then is the core composite material placed in between, and only then half of the mixture is then added again. The resulting product is a fungus-based polyurethane and core composite that was then tested. We tested the mass by using a scale, and the resulting density was found to be around 1.03 kilogram per meter cube. For the durability and friction test, the durability of our product was measured by observing the damage received on the tested composite when we used it to walk on various terrains and surfaces for 50 meters for around a minute.
Here are the findings of our research. First is the damage scale. The first level shows minimal damage with negligible wear and scuffs. Level 2 shows minimal wear with minor surface abrasion and no reduction in thickness. Level 3 indicates light wear with minor scratches and thickness reduction of less than 5%. And lastly, level 4 shows obvious wear with visible abrasion, some small cracks, and possible thickness reduction of 5 to 10%. On the right here, we have the table. This table of damage shows the damage that occurs in composite products. Little or no damage was observed from 500 till 800 N, but from 900 to 1000 N, audible cracking and slight peeling of the surface was observed, but there is no reduction in thickness. Next is figure 1.2. It shows a table of damage experienced by composite, which only consists of resin and cork. As the weight increases, short cracks are visible along the surface lines and possible thickness reduction of 10 to 15%. And now we have figure 1.3, which shows a table of damage observed in both composite materials, composite with resin only and mixed resin mold composite. For both composites, it appears that there are no significant differences in results when testing on the different surfaces. A common factor observed is that asphalt is the most capable of doing damage in terms of minor scratches.
As a conclusion, the result of the study is that composites made from polyurethane cork can I repeat what the fuck? One more time. Conclusion. The result of the study is that composites made from polyurethane cork and mushrooms are better than composites made only from resin. Thank you.
That is the end of our presentation. Thank you, teachers, for listening.